At GLI, we're constantly striving to leverage AI and to optimize our processes and our solutions. In this video, I'll share one of the efforts we're expecting a lot from. Artificial intelligence is a really powerful tool when it comes to creating vision systems that can detect and classify a wide variety of defect types, typically in relation to surface inspections. We built many of those, and now we're exploring how we can add another dimension to our classification networks and give our customers unprecedented flexibility in their inspection. The purpose of a classification network is to define which type a given defect is. Is it a scratch, a pinhole, or a dent? A well-trained classification network can do this with high accuracy, automating a complex inspection task. But the standard classification network also has some limitation. It's essentially a binary classification. It's either a scrap or it's not. And the challenge is that in production of, for example, lacquered wood surfaces, it can vary slightly over time depending on the season, the wood quality, the quality of the lager, and so on. And if you have a fixed tolerance for when the defect is a defect, you risk having disproportionate amount of scrap at different times of the year. This is why we're working on developing a more flexible classification networks for manufacturing companies that want to be able to regularly adjust their tolerances depending on the conditions in their production. We do this by training a neural network with images that are not only annotated with the type of defect, but we also give it a percentage of how severe the defect is rated. So a small mark might only get an 80% rating, but a pressed corner would be 100%. In this way, the network not only learns to recognize the difference between error types, but also to create the different individual errors. As an operator, you can use this to adjust the system's tolerances. For example, to avoid too much scrap, you can increase the tolerance so that the system accepts errors down to 80% level instead of 90%. So you accept marginally worse graded objects for a period of time to avoid excessive waste. Those could then be sorted and packed as second grade. And in the same way, you can easily increase the tolerances again. Training a neural network in this way currently demands a larger workload for annotating and a different type of network. But it will literally give a whole new dimension to the classification network and unprecedented flexibility. It will also eliminate the many iterations of the network that would otherwise be necessary to retrain a network to reflect the changes in the production. So although it's more work up front, it will quickly pay off.